Good morning to all. In last session, we discussed about the gear train. We discussed the simple gear train, how the speed ratio of the simple gear train we can calculate. We derived the formula for that. We discuss about the what is the ideal gear, what is the function of ideal gear or intermediate gear. Now we will discuss about the next topic, that is compound gear train and reverted gear train. I have made a video uh, in which explain what is reverted gear train and compound gear train on blackboard. I will play this video, and if you have any doubt or if you don't clear any doubts while playing the video, you can ask me at same time. So by I will mute the video and or I will stop the video and I will explain this concept. Okay. So we will start with the video. Uh, is this audible to all?
Yes, sir.
Oh. Here there are three shaft A, B, C and four gear 1, 2, 3, 4. Okay, and on shaft B there are two gears are mounted, that is gear 2 and 3. Means in compound gear train, the first shaft is shaft A and left shaft is shaft C. First and last shaft consist of a single gear, but the intermediate shaft, that is shaft B, consists of two or more gear. So this type of the train is called as a compound gear train. the product of number of things on the table divided by P1 and P2. P1 is the gear 1 is driver for gear 2 and gear 3 is the driver for gear 4. Therefore, we can write it as the product of number of things on a drive. This is the speed ratio for compound gear. So, what is the difference between compound gear and simple gear? Only one single difference is compound and simple gear is that in a simple gear, if there are three number of shafts, then each shaft there is one gear is mounted on each shaft. There are three shafts, then there are only three. Or in compound gear, there are two or more gears are mounted on shaft except first and last shift. The application of this compound gear is that the headstone of the same machine. The application of the compound gear. Okay. So next part of the gear train is that the reverted gear. The third type of the gear train. Reverted gear. What is mean by reverted gear? The reverted gear means the gear train in which the axis of first and last shaft are coaxial or coincident with each other. This means that suppose one shaft A and one shaft A. Shaft A here one input shaft and one output. And one has a shaft. In reverted gear train, the input and output shaft are coaxial or coincidence with each other, means their axes are on a same line, but these types of the gear train are required to reduce the velocity or to increase the velocity of the output shaft as the input is constant. Such type of the reverted gear train are generally used in our clock, where the minutes hand and hours hand are mounted on the same shaft, and we want the different motion of the hands. Here the input shaft consists of a gear. Input shaft is A, it consists of a gear 1. There are another shaft B, which consists of a two gears, that is gear number 2 and gear number 3. And output shaft is C, and it consists of a gear number 4. Means reverted gear train is the type of the gear, is the one type of the compound gear train. Only difference is that the input and output shaft are coaxial to each other. If circular module and sorry, if the circular pitch and module of the gear are same, then we can write the equation that is T1 number of teeth on a gear 1 plus number of teeth on a gear 2 is equal to number of teeth on a gear 3 plus number of teeth on a gear 4. This equation that is T1 plus T2 is equal to T3 plus T4 is only applicable when module and circular pitch of the gear is same. Otherwise this equation is not applicable. But in a gear train, the circular pitch and module of the gear is always same. Therefore, this equation is useful while solving the numerical. Okay, this is okay. This is the compound and reverted gear train. So we will take one numerical which is based on a compound gear train. Okay. Here, gearing of the machine tool as shown in figure, the motor shaft is connected to the gear 1, sorry, gear A, and rotate at 975 RPM. Here, the input is given to the gear A and it is rotated in a clockwise direction by 975 RPM. The gear wheels B, C, D, E are fixed to the parallel shaft rotating together. The final gear F is fixed to the output shaft. The output shaft is connected to the gear F. What is the speed of the gear F is the number of teeth on each gear as shown in below. Here we want to calculate the speed of the gear F if the number of teeth on a gear A, B, C, D, E, F are given. That is, gear A consists of a 20 teeth, gear B is consist of 50 teeth, gear C having a 25 teeth, gear D 75 teeth, gear E having a 26 teeth, and gear F consists of a 65 teeth. If we see here, the gear A is rotated in a clockwise direction and it is meshing with the gear B. Therefore, gear B will rotate in anti-clockwise direction. Both the gear C and D are on a same shaft. Therefore, gear C also rotate in gear C will rotate in anti-clockwise direction. Now, if we see here, gear C is meshing with the gear D. Gear C is meshing with the gear D. Therefore, gear D is rotated in a clockwise direction. Okay, and gear D and gear E are mounted on a same shaft. Therefore, rotation of the gear E is same that of the gear D. That is, gear E will rotate in a clockwise direction. And here, if we see, the gear E is meshing with the gear F. Therefore, the motion of the gear F is an anti-clockwise direction. Means if input is given to the gear A, it is clockwise direction, and output is obtained at gear F is the anti-clockwise direction. Okay, so we have to calculate the speed of the gear F is the number of teeth of the given number of teeth on gear A, B, C, D, E, F are given. So solution, that is speed of the gear A upon speed of the gear F. If we see, this is a compound gear train because input shaft consists of a gear, only one gear, output shaft consists of only one gear, that is gear F, and intermediate two shaft consists of a two gears on each shaft. Okay, so this is the compound gear train. So speed of the gear A upon speed of the gear F is equal to TB into TD into TF divided by TA into TC into TE, where T represent the number of teeth and suffix letter represent the gear. So number of teeth on a gear B is equal to 50, number of teeth on a gear D is equal to 75, and number of teeth on a gear F is equal to 65. Divide by number of teeth on A is 20, number of teeth on C is 25, and number of teeth on E is 26. So this ratio is equal to 18.75. We know, that is, we given that the speed of the gear A. Speed of the gear A is given, that is, gear A is rotating at 975 RPM. Therefore, if we put an A, that is speed of the gear A is equal to 975 divided by 18.75, which is equal to 52. Means speed of the gear F is 52 RPM. Okay, the answer is 52 RPM. Means if we see, the input is 975 and output is 52 rpm, means there is a large reduction in a speed of the output shaft, and this is only due to the gear train. And rotation means the gear A is rotating in a clockwise direction, but gear F is rotating in an anti-clockwise direction. Okay, so if we see here, the large speed reduction is obtained because of use of the gear train, and direction of the output shaft is also reversed due to this gear train. This is the application of the gear train. Okay, so in this is enough for today's lecture. In next lecture, we discuss about the numerical on compound and reverted gear train, and we will start with the epicyclic gear train. Okay, so if you have any doubt regarding today's session or about the gear train, you can ask me here, because we have some time to discuss some points. Is anybody have any doubts? Okay. Okay, so we will stop here for today. I will share the attendance link. Mark your attendance. Thank you.